Alright, okay, let's do a quick recap before we go on with the lesson, yeah? Oh, what have you all been doing? What's all this couple stuff? Is this coding? Hey, you okay now? Yeah. Okay. Welcome to class. You must check your PM, right? Yeah. Hey, you all just started recording, right? Start already, yeah? Oh, okay. I think I need to edit out that part. Okay, ready? Yeah, so we do a quick recap of what we learned in the previous lesson. If I ask you to recap now, then you have immunity for next lesson. Yeah? Okay. Anyone absent today, sorry? No? No absent? Share with us what you learned in the previous lesson. Okay, you learned about surface tension. How do you explain surface tension? Okay, surface tension can be explained by the bonds between the water molecules. And what are these bonds called? Sorry? Says that there are bonds between the water molecules. And what are these bonds called? Sorry? Close? Hydrogen bonds. Yeah, hydrogen bonds. Okay, because yeah, so the bonds that hold the water molecules together, we call them hydrogen bonds. Hydrogen bonds occur between partially positive and partially negative atoms. Okay, so the thing is hydrogen bonds. Can hydrogen bonds occur between other things other than water molecules? Okay, it's possible. So let me give you some examples. Let's say I have a molecule like this, nitrogen and hydrogen. Nitrogen is partially negative, partially positive. Is it possible to have hydrogen bond this way? Possible. Yeah. So as long as you have partially positive beings and partially negative beings, just think of them like magnets can attract. Okay, plus attract minus. Yep. One thing to take note of, hydrogen bonds always involve one party being hydrogen. Okay, if not, we don't call it hydrogen bonds. Yeah. Give me another example of hydrogen bond. Let's say I have another functional group here. It looks something like that. Right, it is possible to have a hydrogen bond also. Yeah. Then positive, negative, let's go. Okay, another hydrogen bond. Again, it involves hydrogen as one of the parties. Okay. So hydrogen bond doesn't only occur between water molecules, can occur between other molecules also, as long as you have a polarity involved. Okay, anything else that was learned other than hydrogen bonds? We want to recap a bit more previous lessons. Yeah, Alpha, you never bring notes, right? Then use your brain power. Okay, Alpha. Hydrophobia. Hydrophobic. I remember what it was? Hydrophobic something. Okay, hang Start with I. Interactions, thank you. Hydrophobic interaction. Okay. What is hydrophobic interaction? If we recall last week as we were playing hydrophobic sand, remember how the sand kind of clumped together in the water? When you pour the sand into the water, they didn't just trickle down to the bottom, they actually clumped together. It's as though there was a force bringing them together. Okay, we call that hydrophobic interaction. If I were to go backwards, a little bit more summary, hydrogen bonds occur between polar functional groups. Hydrophobic interactions occur between non-polar functional groups. Let's go one more step back. What results in polar functional groups or polar covalent bonds? Okay, can you recall? What results in a polar covalent bond? What makes a bond have partial positive, partial negative? Yes. I hear electronegativity. Okay, what about? There's a difference. Good. Okay. If there is a difference in electronegativity, that difference needs to be large enough, okay, to be considered. If the difference is not large enough, okay, if it's not large enough, then we consider it non-polar. What is an example of a non-polar covalent bond? Okay, what's an example of a non-polar covalent bond? It was in one of your CAs. Okay, I heard CH. Who said CH? You don't be shy, I'm not going to throw a marker at you. Okay, correct, CH. Okay, CH is an example of a non-polar covalent bond. If we want to look at polar covalent bonds, we have things like OH, we have things like NH, and then you saw things like COO. These are all polar covalent bonds. Okay? This is just a recap of the past two lessons that we've had so far. Okay, before we move on. Yeah, I'm going to take a pause now for you to slowly draw back what you learned. Then we're going to move on to the next, to complete this particular CA. I believe I asked you to go on and try it. Did I? No. Then let's go to the last part. Okay, can everyone go to CA 1.1b? Go to E. Go to part E. Okay, CA 1.1b, go to part E. Okay, now in your pairs, I would like you to think through this particular question. So far, we've talked about two kinds of interactions. There's hydrogen bond, and then there's hydrophobic interactions. Okay, what happens if we have this particular scenario? Here is a sodium ion. Okay, positively charged. Here I have a chloride ion, which is negatively charged. In your pair style, can you discuss how will this particular molecule or water molecule interact with this one or this one? How will it interact? How will you rearrange the water molecule to interact with sodium ion or a chloride ion? Okay, a quick 2-minute discussion, and then we'll invite some people up to draw for me on the whiteboard. You okay? You don't have your iPad? Okay. Next time you should bring up. It's a bit smaller, just worry about heights. So if I invite you up, yeah, I don't want to see passive thinkers in class. As I'm walking around, you should be trying. Yes? Oh, okay. Not press up. Put your one over there. You go and you will pick papers. a few lines here already. Okay. What is the partial charge? Don't know the. That's electronegativity. Partial charge means whether it's marginally positive or negative. What's the partial charge of hydrogen? Positive. Makes sense or not? Okay, I'll let you to present. Hello. You present. Okay, here's the clue. You must apply what you've been learning. What's the partial charge of hydrogen? What's the partial charge of oxygen? Negative. Okay, there's a logic to this. So how will these ions attract this water molecule? Hey, Jeanette. Okay, ready? Okay, let's welcome Jeanette. Give her a round of applause. Jeanette, you can bring up your friend. Yeah, just bring Soyan up. Just bring her up. Okay, come, two of you. Come. You don't need to be shy. Okay, random side. Okay, go. We don't know. Hey, you can draw another water molecule. Come and draw another one. Yeah, don't need to use mine. Come and draw other water molecules. How will water molecule interact? Okay, everyone, you look to the board. Is there a logic being applied here? Yeah, it's not. Jeanette didn't blindly just bring water molecule and then anyhow attach, right? There's some logic to this, right? Rohit, what's the logic being applied here? You're nodding your head, right? So you. Okay, what about the plus minus thing? Okay, yeah. Right? If it's oppositely charged, they will attract each other. Okay? So, that is what Jeanette is applying over here. Okay. I would like to show you how water molecules will interact with an ion. Okay? Imagine I have many water molecules. What will it look like? I imagine I have many water molecules. Watch the whiteboard. Possible? Yeah, I just max out every space up. All the water molecules will max out the spaces. Of course, this is in 3D, imagine. You have water molecules on the surface sticking out also. Okay? So what would the other side look like? Could I get you to draw it in? What if I also have 1, 2, 3, 4, 5, 6 water molecules? How would the 6 water molecules interact on this side? Yeah? You also get a star shape, right? Okay? So could you draw it down? If we spend some time to draw it down, how would the other side interact? Okay, once done, discuss with your partner. Is this a hydrogen bond? It is being, yeah. Will you consider these hydrogen bonds? Okay, very simple. Yes, no. Will you consider this hydrogen bond? Yeah, why? Rolly? Hey, just ask that. Oh. Okay, what's wrong about this? Oh, okay, you say it's not hydrogen bond, right? Yeah, hydrogen bond is drawn line. So, do you all think it's hydrogen bond or not? That's my question, right? Okay, so I see a lot of you doing this. A lot of you will join this, right? Remember, this represents hydrogen bond. These lines, right? But then my question to you is this a hydrogen bond? Yeah? If yes, why? If no, why? What makes a hydrogen bond a hydrogen bond? Right? Jeanette, what do you say? Say louder. Say louder. What do you say?
Hydrogen bond is the ion has there's no hydrogen bond, but it's like the hydrogen bond is the ion has
Okay. Oh, okay. So you're saying, okay. So is this considered a hydrogen bond? This dot dot? No. But if it's this one, if it's this one, will you consider it a hydrogen bond? Possible? Okay, so we kind of pick all the definitions, right? Hydrogen bond is between, okay, number one, you need hydrogen. Okay, so there is a number two, okay, to consider a hydrogen bond, it needs to be between two polar covalent bonds. Okay, yes. Like here to here? Oh, okay. What bond is this? This is a covalent bond. Yeah, this is a covalent bond. Okay, this is a covalent bond. It's not a hydrogen bond. Remember, hydrogen bond is like just magnets attracting each other. There's no sharing of electrons involved. Okay, so if we use this, hydrogen bond requires hydrogen. It needs to be between two polar covalent bonds. Will we consider this a hydrogen bond? Which is also not considered. You look at this fellow over here. This is an ion. It is not covalent in nature. Okay? So actually, it's not a hydrogen bond. There is a special name for this kind of bond that you will learn next time in chemistry. I just introduced to you. It is called ion. Okay, ion comes from the word, from these fellas. This is an ion, right? Negative ion, positive ion. It's called ion. Dipole. Dipole means di means two. Okay, where does the two come from? Dipole. Dipole means two poles. There is a positive pole and there's a negative pole. A dipole is an ion dipole interaction. Okay, but it's not a hydrogen bond. Okay, right after this, we will do a summary map of all the bonds that we've learned so far, so that you can see the slight differences. Okay. Yes.
How would you like define a hydrogen bond?
How will you define hydrogen bond? Okay, if you look into your notes, there's actually a very long-winded definition. I'm not sure if it makes sense to you. If you go word by word, it's exactly what we've been talking about so far. Hydrogen bonds formed between a hydrogen atom, covalently bonded to electron. If you try to draw this out, it's the same thing that we've been talking about. I will not ask you to define a hydrogen bond because it's a bit too much to define. It's easier to understand than to define it. Okay? I'm going to erase the board. Is that okay? Now let's do a quick summary of all the bonds we've learned so far. Okay, I sense that there is a little bit of confusion, so let's walk before the bonds so far. Okay, number one, we've learned quite a few things. We learned that there are covalent bonds, and these covalent bonds can be either polar or non-polar. Examples of non-polar covalent bonds: CH. Examples of polar ones are NH, OH, COO. So let's give some examples. Let's say I have a water molecule over here, OH. Okay. This is what I will consider a polar covalent bond. Right. This over here is a polar covalent bond. Yeah. What if I have two water molecules side by side? Let's say I have one like that, now like that. This interaction between the water molecules is another bond. This is a hydrogen bond. Let's introduce another party. What if I have an ion over here? Let's say just now we were playing with chloride ion, right? You can also have an interaction. This interaction we refer to as ion dipole interaction. Okay, so the variety of bonds that we've talked about so far. The last one that we also talk about is if there is a lot of non-polar bonds. Let's say there's a CH. Okay, they will clump together. Okay, this one they interact via hydrophobic interaction. Okay, so you have one, you have two, you have three, you have four kinds of bonds that we talked about so far. Okay, this is just a summary for you. So again, if you cannot draw fast enough, you can always take a photo and then include it to your notes. Right, that's the power of one note. Henry, yeah? What is this one? A polar covalent bond. Yeah? Hydrogen bond. Ion dipole interaction. Hydrophobic interaction. Okay, for those that are fast, okay, let's complete last one. Sketch how water molecules interact with the phospholipid molecule below. Now that we know the different kinds of interactions, how would water molecules interact with that molecule below? I'd like you to draw at least 5 water molecules like that. Okay, draw 5 of these up. Can you show us how it interacts with that big molecule below? Okay, this is the ultimate test. You look at the molecule, I would like you to observe and then apply. Where would water molecules interact with on this molecule? This big molecule comes with many things. There are ionic parts, there are polar parts. How would the water molecule interact? Okay, so how will you draw it interacting with the N plus? Yeah, right? You're applying the same logic here, right? Oppositely charged things will attract each other. This one is will be partially negative, but this one is an ion. Possible? Yeah. Yeah, you apply the right logic. Wait, is it? Why your water molecule is H, then 2 oxygen? Okay, this is good. I see you practicing. You apply in class. As I go around, I can help you immediately. But if you don't try in class, I cannot help you. How are you? I see your example. Can you try? Do not what? Okay, do not copy is fine. Could you just show me where you would attract one water molecule? Sure, but how would the oxygen and hydrogen interact with these parts? Yeah. So will you take the hydrogen to attract here or the oxygen part? Okay. Okay. Yeah. That's the logic. Right? Let's see. Yeah. bonds involved, it's not. Okay, as I'm walking around, I see good work. I see a lot of you trying. Okay, let's have a look. Okay, this is just a sample. This is just a sample. As long as you apply the same logic, it's fine. My oxygen is attracted to this positive charge, because oppositely charged. My hydrogen is attracted to the oxygen here because this oxygen will likely be partially negative. Here I have a lot of you correctly identified that this ion here is negatively charged. So you will attract all the hydrogen parts because it's partially positive. Right? Then some of you identified here may be partially negative, so it could attract the hydrogen. Okay? So apply the idea opposites attract. Opposites attract. Yes, Henry? Okay, it is covalent here, it is covalent here, it's covalent here, it's covalent here. But just at the oxygen is an ion. Just at the end, the oxygen is an ion. Yes? Which one? Like this one? Every time you see a fully charged ion, it's not considered a hydrogen bond. As long as you see a minus or a plus, you consider it a ion.
Then the one without plus, right?
Yeah, so like this one, without you don't see a minus or plus, that's not an ion. Yes. Oh, okay. So a question: could water molecules bond with the CH3? Okay, then we go back to the idea of CH3 is actually this, CH3. It is a carbon with many carbon-hydrogen bonds. Carbon-hydrogen bonds are non-polar in nature. So there is no attractive force to it. Okay? Do you know what all these zigzags are? Okay? All of these zigzags represent carbon and hydrogen. It's just a biologist, we are a bit lazy. So it goes something like that. If you were to see a zigzag like that, it means that there's a carbon at every point. Carbon, 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 carbon. And then each carbon can bond with two more things. So next time if you see this kind of a skeleton, a zigzag, this is what we are trying to show. We were just lazy. But this is what we're trying to show. And again, it's a lot of carbon and hydrogen bonds. These are all non-polar bonds. So you expect that there's not much attraction. Yes?
You put dot when the oxygen doesn't have a sign.
Oh, yeah, my mistake. Some of them I should put lines instead. Like over here, let me put a line instead. Okay, where would I put lines? Okay, this one can be dots. This one I should put lines. Yeah, because it's not an ion. Can I put lines here? I can put lines here also, because it's not an ion. Okay? I need to tell you, will I ever ask you to draw all this? I won't. Okay? I just need you to understand. What's the concept here? Opposites attract. Okay? Apply that concept already, opposites attract. I won't ask you to draw a hydrogen bond, ion dipole interaction. I won't. I just want you to be able to be able to apply that opposites attract. Yeah? Technically, in the chemistry field, they represent different things. Yeah? But right over here, I should represent these parts with the lines. Okay, because there's no ion involved, so I should represent with the lines. there are some regions that love water. Can see? Right? Clearly there is a region in this molecule that loves water, it attracts water to itself. Right? Regions that love water, we call them hydrophilic. Okay? Regions that love water, we call them hydrophilic. Hydro means water. Philic means you love something. So if I'm a hydrophile, means I love water. Yeah? I'm sure you've heard of other files before. Okay? Nothing. You laugh so hard. Okay? Are there regions in this biomolecule that does not attract water? Yeah, you look at to the right. Everything that has carbon and hydrogen does not like water. And we have a term for that. We say it is hydrophobic. Phobic means you fear things. Hydro means water. I would like you now to use two different colors. Highlight the hydrophilic regions of this molecule. Highlight the hydrophobic regions of this molecule. I say again, can you use two different colors? One color to represent regions that love water. Another color to represent regions that do not like water. So hydrophilic, hydrophobic. Right? So this is the hydrophilic or phobic part. Philic part, okay. Okay, can you highlight the hydrophilic regions and the hydrophobic regions? What do you think? Yeah, it is considered because if these are all negative, right, then this middle part is pulling that part. Which side? Like all of these fellas here. Yeah. You mean that extreme and water molecule? Why water molecule don't want CH3? Because CH3 is made up of CH bonds, which are not yeah, so they have nothing to attract, right? Okay, are you done highlighting all the hydrophobic, hydrophilic regions? Okay, good. I see a lot of you coloring this region here as water loving. Yeah, these regions here are very water loving. When do you color as the water hating parts? Now, everything here is water hating. Because they're all made out of CH bonds, non-polar, nothing to attract. Okay? So you want to color all these regions here as hydrophobic. They don't like water. Any questions? We're going to stop soon. Okay, if you want to test yourself, right? I'm going to draw something on the whiteboard. Can you tell me if this particular molecule is a hydrophilic molecule or hydrophobic molecule? Do you think you like water or you dislike water? Okay, so a quick test. Is this a hydrophilic molecule or is this a hydrophobic molecule? Okay, those who say hydrophobic, raise your hand. Those who say hydrophilic. Okay? So let's try other things up. What about what other things we encounter? Okay. What about this molecule here? Is this a hydrophobic or hydrophilic molecule? Hydrophobic? You see? Yeah? Why? Why? Again, always go back to the why. Why is this considered hydrophobic? A lot of CH bonds. CH bonds are non-polar. Okay, we make use of the words, okay? CH bonds are non-polar. Did you know oil? No oil? They use for cooking. It is made up of a lot of these kinds of molecules, just made up of CH. I don't know if you can see the link now. That's why oil and water don't mix. If I throw oil into water, it don't mix, right? Because oil consists of a lot of these kind of molecules. Do you know your waterproof shirts? You have waterproof shirts now. Water land on it, just bounce off one. I want to make a guess what is coating the surface. Yeah, a lot of things with CH bonds. Make sense now? You know, I saw this very funny news article. A lot of drunk people, once they leave the bar, right, first thing they do is they'll pee outside the bar. They just drunk and then go outside and then they'll just pee onto the walls. So you know what this bar did? Yes, they sprayed the whole wall with hydrophobic paint with a lot of CH. So what will happen? So when these drunk people come out, they start peeing on the wall, right? Immediately, pee and then bounce back to their pants. Your umbrellas, the umbrellas that you use, is coated with a lot of hydrophobic material, so that when water lands, it will bounce off. But you notice your cotton shirts are the ones that get really wet very easily, right? Cannot quite get the water off. That's because cotton shirts have a lot of hydrophilic things, have a lot of hydrophilic parts. So next time you see something that doesn't attract water, you go back to this logic. Actually, a lot of these waterproof things are made up of non-polar bonds. Yeah? So every time you see something, you realize now actually there's a science behind it. It goes back to this science. This particular molecule, however, notice is a bit special. You highlighted half of it as hydrophilic and the other half as hydrophobic, right? We cannot say that this molecule is totally hydrophobic or totally hydrophilic. Okay, there's one last term I'd like to introduce to you today. So far we've learned what hydrophobic is, hydrophilic is. The last word is amphipathic. Amphi means both. You know amphibian, like a frog? Yeah, like a frog. Amphibious. They like land and water. Amphi means both water and it both likes water and doesn't like water. Okay, so amphipathic. I can describe this molecule as being amphipathic. It has hydrophilic regions, it has hydrophobic regions. Let me give you another example of a amphipathic molecule. Okay, here is a molecule that comes with a lot of CH bonds. And then at the end, I go and add something like that. Okay, so it has both hydrophilic regions, it also has hydrophobic regions. We will consider this entire thing as amphipathic. That means it has both regions involved. Okay, and that's the final term I'd like to introduce to you today. Hydrophobic, hydrophilic, amphipathic. After today's lesson, I will not be introducing many new terms anymore. We are going to just use these same terms over and over again across all the molecules. From fats, to proteins, to carbohydrates, we just apply the same concepts over and over. Okay, with practice, you'll get easier. For now, I've just been introducing you the vocabulary tidy up your notes. Okay, tidy up CA 1.1A and 1.1B. Okay, I know many of you have submitted CA 1.1A as requested from you last week. Can you tidy up this particular CA 1.1B? Once done, please submit. Okay, I've given you a lot of time in class to do it. So once you're done, just submit it immediately to Google Classroom. To end of today's lesson, can you download CA 1.12? Sorry, CA 1.28 lipids into your notes? Okay, can you download this? And as homework, or if you want to, you can complete in class and there's no homework. Can you complete this? I believe this is something you have done before in JH2. Something we've done before in JH2. Next lesson onwards, I'm going to go into fats, lipids, fats. Okay, we've done this before in JH2, so we use this as a recap for yourself. You also remember what triglycerides are? Okay, so that's the recap for you before the next lesson. If you complete it now, and I check and you pass, right? Then tell me you're ready for next lesson. If not, this will be your homework for today. Can you complete this? Can you draw for me what it will look like when you bond one glycerol and 3 fatty acids together? And what other molecules will be produced when you bond these fellas together? Okay, so the remaining time, can I get you to do this now? And I'll go around to answer any of the questions that you don't understand.